So I had a bit of a crash earlier. Get to restart on 34. You are not taught all of matrices in 22-23, at least if you were taught by Mr. Milbrath in the state of Tennessee. And a matrix times its inverse is the identity matrix. That is something that I didn't teach you last year, and matrices aren't actually in the pre-calculus standards either, at least not for the course that my students have to be taking. Maybe it's something I should do with y'all after your challenge exam, but I don't know. Anyways, what this is saying is if I take this matrix, which is 3, -x, x, and 4, and I multiply it by its inverse, which we'll call ace to the -1, and it's got 4 things in it, I should get the identity matrix 1, 0, 0, 1. That's the gist of it. Now, doing this by hand is a relatively time-consuming process. So we're going to just cheat. We're going to let x be something funny. I'm going to use, I don't know, 12. All right, let's see how good a TI-84 is. So second matrix, edit. -3, -12. This is probably why it wasn't working for me in the first place. 12, 4. So I overtyped. Now let's see how good a TI-84 is. Second quit, second matrix A, and there's an inverse key here. I'm going to see if it'll do it. That's what I got. Now let's snip this, because Lord knows I cannot keep up with that in my head. And let's see which one of these might be right. Doesn't look like anything there, does it? But you see this out here? That might be the kicker. That might be the kicker. All right, so let me erase all this so I've got some room to write. I'm going to look at each and every answer choice. All right, this one doesn't make sense. -1, x was 12. Yeah, it's not A. That one's just garbage. I wish it was the right answer, but it's not. If I plug a 12 in right here, that becomes 1 over 144. All right, so let's just think about this. We can do this kind of by hand. 1 over 144. And remember, I let x be 12. So 3. This would be -12. 12, 4. Let's see if we get this result. Here I would have 3 over 144 inside the matrix, -12 over 144 inside the matrix, 12 over 144 inside the matrix, 4 over 144 inside the matrix. 3 over 144 is not going to reduce to 1/39. Hope I'm not wasting some time here again. If 3 doesn't work, -3 won't work either. Now will it? I know x be 12. Oh, fudge, I shouldn't have done that. Really shouldn't have done that. That makes this 0. Oh, all right, let's try this one. Oh, plus Milbrath can't add. Why am I saying 144? I am not having a good math day. Let's go back and check the one I had. That would be 3 over 156 minus 12 over 156. 12 over 156. I hope you caught that. 4 over 156. A 3 over 156 is probably not going to reduce the way I want it to, but who knows? This is one of these days I can check myself. I don't think it's going to happen. Yeah, it's a 52nd. So I still can throw those away. Let's look at the last one. Maybe it's this one. I would have 144 and 12, which is 156. 4, 12, negative 12, 3. And I start off with 4 over 156. 4 over 156. Back as a frac. This is looking like it. 1/39. Now, I've already cleared off my calculator from earlier because I'm stupid. There she is. There's the 1/39. Bring that up to the forefront so I'll have it. Whoops. So I got the 1/39. Here I'm going to have 12 over 156. I can't even push buttons today. Back is a frac. 1/13. Cool. Checking out. Looking good. This is going to be negative 12 over 156. Back is a frac. I'm looking for negative 1/13. Cool. I'm feeling pretty confident here. All right. So, what you need to know is how to cheat. And here's what I did. I made up a number. I put the matrix in the calculator. I pushed the inverse button. I don't even know if I've even shown you guys that one, or at least talked about it, but it's right there. It's right on matrix. I pushed the inverse button and I checked for equivalency. That's all I did. Nothing more. Checked for equivalency. And there's other ways of doing this one. That's not the only way to cheat without actually understanding matrices. What are the foci and the ellipse of this equation? Oh, man, that's a brutal looking little thing, isn't it? You guys have no idea what to do on this one. And is there anything you could actually do on this one in a calculator that would enable you to cheat? Probably not. So just so you don't have to read my handwriting, let's go get the standard form of an ellipse. This used to be a big thing. There she is. Let me see if I can get a better image. Ah, there we go. That one's not too bad. It's kind of like a circle. It is. They're very similar. I actually haven't had a chance to teach ellipses in years. It used to be an Algebra 2 standard. It was a pre-calculus standard for the longest period of time. But we just got away with it because more and more kids couldn't do it. So anyways, I need to be looking like this. That's what I need to be looking like. And does this actually tell you where the foci are? Tells you where the center is, doesn't tell you where the foci. The foci are 2 points along the major axis. So we're going to need another formula here. Seems like it's just a little Pythagorean theorem to some degree. There's some formulas here. Where are they? The foci is the equidistant point along the center. And I'm almost certain it's found by doing a squared plus b squared. But again, I haven't done them in so long. Here's some nice things. A is greater than B. The coordinates of the vertices are plus or minus AB. The focuses are plus or minus C. Yeah, so it's Pythagorean theorem. But it's actually a little bit different, isn't it? It's A squared minus B squared. All right, let's just take this image. Again, forgive Milbrath. Milbrath hasn't done these in years. So Milbrath didn't want to write down the wrong formula. I remember the math on how to get there. I just didn't remember the exact formulas. I don't know how to cheat in a calculator on this. I wish I did for you, but I don't. Anyways, there we go. We have some other cool things. The area of an ellipse, pi AB. I've derived that one in the past. I remember that one. Perimeter, I've never derived that one. I've just always trusted that guy's right. So let's take our complex equation and let's manipulate it. The center is actually usually pretty easy to find. What we're going to do is we're going to complete the square twice. We'll have x squared minus 6x, leave some space, plus 6y squared plus 36y equals negative 57. And we're going to have to do some interesting things here that you may not be comfortable with, but we're going to take half of negative 6, which is negative 3. We're going to square it and get 9. And we're going to add 9 here, and we're going to add 9 here. Now this piece factors as x minus 3 quantity squared. Here we're going to do something a little funny. We're going to pull a 6. And half of 6 is 3. We're going to square it and get a 9. Now, the reality is I'm not adding 9 to both sides. I'm adding 6 times 9 to both sides. And 6 times 9 is 54, last I checked. Now, y plus 6y plus 9 factors as y plus 3 squared. And if I add all my crap together on the right, I think I get 6. And I should, because I'm going to have to do a step here and I'm going to divide out. Now I'm going to divide both sides by 6, and I'll get the one that is being talked about. And notice that's the form. Here we have that. All right, now it specifically says where A is greater than B. So where A is greater than B. The coordinates of the foci are at H plus or minus CK. This is H, this is K. All right. And to find C, C squared is A squared minus B squared. So C squared is, man, I'm trying to remember the last time I taught this. I bet it was 2016, maybe 17. The last class I taught this to probably had Anna, Fernando, Eli, Darla. Lots of good kids in that group. Lots and lots of good groups, good kids. 6 squared minus 1 squared. And I hated every minute of it. Anyways, I'm going to get C squared is 35. So C is root 35. Which does not appear to be any of the answer choices up there now, does it? Why doesn't that look like any of the answer choices that are up there? Pause. Yep, moron moment. Huge moron moment. literally says c squared is a squared minus b squared. And this legit is a squared, and this legit is b squared. So c squared is going to be 6 minus 1, which is 5. So c is root 5. So gone, 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 gone. Choice C. There we go. I was looking for root 5s because of what I have over here up to the right. The foci is h, which is 3, plus or minus root 5 up here, and then k, which is negative 3. So there you go. There you go. Something I hadn't done in years. All right, which of the following is an equation for the graph shown? If you are in my pre-calc class, you should know how to graph things. That's what we're going to do. We're going to legit put our TI-84 into radian mode. We're also going to adjust the window. I'm going to do a 0 to 2 pi. Now, if you're in my pre-calc class, like you should know some things. Like you should be like, no, 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 because sine starts at the middle and rises or falls. The only two valid answers are these. They're the only two. Now, if you're also in my pre-calc class, you should know some other things too. Like if you look at choice C, the period, the period is 2 pi over 3, which means we're going to see a full cycle in about 2/3 of pi. The correct answer is C. For example, B, the period is 2 pi over 1/3, which is 6 pi. Then it's obviously not B. But anyways, if you forget things because you're one of those kids who has like test anxiety, whatever, mode, put her in radians. And again, I'll show you it's not example B. Go to y equals -2 sins of x over 3. Let's clear that out. I'm going to play with the window. Let me do a zoom 6 first because I don't know what I did last in this calculator. But in order to see the graph that they have, I'm going to have to adjust some window settings. I'm also going to adjust the y min to be -2, the y max to be 2. So the y min is -2. The y max is 2. And we're going to go from 0 to 2 pi. I'm legit going to type in 2 freaking pi. And then I'm going to hit the graph key. See, that was choice B, not B. So let's speed this function up by putting a 3x in there. And that will speed it up to some degree. And there she is, all day long. Choice C is the right answer. Looks just like it. If it looks like a duck, quacks like a duck, it's a duck. For dependent events, hey, cool, you guys actually had this. For independent events, where the probability of A is 0.3 and the probability of B is 0.6, I have no idea why this question's on here. But the probability of A or B, and this is if independent, is the probability of A plus the probability of B, which, if I take 0.3 and 0.6 and I put them together, I get 0.9. 38 can be done using an identity. There is an identity for cosine of twice theta. There's actually several. You could think of it as cosine of theta plus theta. There's lots and lots of things you could do. Or you could take the arc cosine, and this is what I'm going to do, because it's a test and seeing how strategies you have of 4/5. That would give me theta, last I checked. All right, so if I take the arc cosine of 4/5, give me in degrees here. I'm still very much a degree-oriented person. I should know this one too. It's about 36.87 degrees. Now here's what I'm going to do now. I'm going to double it, and I'm going to take its cosine. And I'm going to get 0.28. I feel like I've done this problem before. Maybe I haven't. That is most likely 7/25. And it is. And there's that one.